Okay, well, let's greet each other properly. Good morning. All right, this is Mr. Ainsworth. We're going to get into section 9.2 today, and we're going to be talking about multiplying monomials. It's going to take a lot of properties from the past, especially your properties on exponents that we went over in former lessons. You'll see me review those, and some other properties too. So let's get with it here. Let's talk about the key points of how to multiply polynomials. In this lesson, we start with monomials. Monomials meaning single terms. Okay, a couple things we need to do before we do this is first one is called commutative property. Okay, so let's state that off on the side. Commutative property talks about how the order in either multiplication or addition, either one, does not matter. Okay, so if I say something like this, A times B, right there, if the order doesn't matter, then that equals B times A. So AB equals BA. The order doesn't matter in multiplying. We're going to need to know that today because I'm going to be switching the order, regrouping, all kinds of things. Okay, so let's put that down in English, okay? Order does not matter. Okay, it does not matter when multiplying. Okay, it matters in division, it matters in subtraction, but it doesn't matter when you're dealing with multiplication. So it doesn't matter multiplication. A times B equals B times A. In other words, 2 times 3 equals 3 times 2. The order doesn't matter. Okay? Now the associative property deals with grouping, whereas the commutative property deals with order. Okay? So when I regroup terms, I'm going to be using what's called associative property when we're multiplying a few terms. So for example, A times B, then times C. Notice how I grouped up the first two terms there? A times B and then multiplied by C is the same thing as taking A times whatever B times C is. So instead of grouping the first two terms, I can group the second and third terms together. Okay, back in grade school, you saw something like this. 2 times 3 times, let's say, 4 is the same thing as 2 times 3 times 4. All right, it doesn't matter which two numbers you start multiplying first. When you're done, you get the same result. So let's do it together. Let's just practice here. Look at the 2 times 3. 2 times 3 is 6. And now 6 times 4. So the left side is 24 if you start with the first group. If you're on the right side, you start with the 3 times 4. 3 times 4? 12. And now multiply by 2? 24. So whether it doesn't matter what the group is, it doesn't matter the order when you multiply. And that's what associative property is all about. So when I say regroup, that's okay in multiplication. It's not okay in division. You can't just regroup any way you want. You got to be careful there. And it's not okay in subtraction. You're going to end up with different answers. But regrouping and reordering in multiplication is okay. You can switch the order. You can regroup. You can do all that. You're going to still end up with the same result. Give me a thumbs up if you're with me so far on that. Okay, that fits your intuition since grade school because we've been doing that for a while. Okay, now we need to review the laws of exponents because they're going to come up all day today. All right, so we're going to put them all here first, and we can refer back to these rules anytime we want. Okay, the product rule goes like this. The product rule means that A or X are variable. You can use X here. X to the nth power, let's say, times X to the m power. Okay, when you multiply like variables, what do you do to their exponents? You add them. So this is going to be equal to X to the n plus m power. When multiplying exponents, you add their exponents. Let me see, make sure I say that correctly. When multiplying variables, you add their exponents. Let me give you an example in blue here. X squared times x cubed. Okay, x squared means you're multiplying 2 x's. X cubed means you're multiplying 3. So really, how many are we multiplying in all? 5 of them. How do you say that? If we're multiplying 5 x's together, we get x to what power? Yeah, so x to the 2 plus 3. That's what you should be thinking. That's your mental step. And then, of course, you get x to the 5th. So we want to add exponents here. When you multiply variables, you simply add their exponents. Okay? Power to a power rule. Okay, power to a power rule looks like this. If you take x to the nth power and you give it a hug and you raise it to the m power, okay, you have power x to the nth power raised to the m power. That's called power to a power. Do you guys remember what we do? Oh, very good. You multiply the exponents. Very good. So you get x to the n times m power. You multiply your exponents. Let me give you a simple example on the side here. If we take x squared and we raise it to the third power, which we can say cubed if we want. We can say x squared cubed, or x to the second power raised to the third power. We want to multiply those exponents. So what would the end result be, guys? X to the sixth power. Okay. So what I'm trying to do right now is just review everything we learned in a former chapter, because we need it today. So just review a little bit, and then things will be a lot easier to handle when we get there. Okay. Now, product to a power looks like this. This is going to happen a lot today too. A product means A times B. Okay. Product means multiplying two things, or you can multiply three things. Actually, a product can be multiplied into many things. All right. But in general, A times B. We want to take that product and raise it to a power. So let's do that. So x times y, let's say, raised to the nth power. Okay, x times y is called a product. Okay, we want to raise it to a power n, where n could be 2, it could be 3, in reality it could be any number we want. All right. What we have to remember is that we take both the factors, x and y, and we raise them to the power. So we're going to take x and raise it to the nth power times y to the nth power. We raise each factor to the power. In fact, let me put that in writing, okay? So raise, okay, each factor, all right, to the nth power. Nth power. You guys might remember me saying, if we square a product, you might remember me saying square everything. Or if we take it to the third power, I say cube everything. Who remembers me doing that with you guys a while back? Yeah, look at all the hands go up. We're going to do the same thing today. We're going to square a product. We're going to cube a product. We're going to do all kinds of crazy things. Okay? And the quotient rule, quotient is A divided by B. That's a fraction. Okay? And what we want to do is recall how we take a fraction, which is called a quotient, to the power. That's the nth power right there. Okay? And when you take a fraction to a power, think simple. All you do is take the numerator to the power, and then take the denominator to the power, and then you simplify what you get. Okay, so let's start out by taking A to the nth power divided by B to the nth power. You just raise both the numerator and denominator to the power. Okay? And all those rules are going to be used at different times, depending on what we have. So we can flip back up here and refer back to all these rules as we go. So keep that in mind. All right, so here we go. A number example 1 here, let's read first. It says multiply the monomials, okay, and simplify using the commutative and associative laws as well as the laws of exponents. Okay, now look over here on the right, this right here. I want to show the regrouping and show all steps to develop good habits. And keep this in mind, you guys have been through this material before, so don't work ahead of me. All right, we want to develop good habits, so I'm going to step it out all the way through. And then later on when we practice, we're going to be stepping it all the way through and show the regrouping, show how we simplify, show all that so we develop good habits and we become better this year. Okay, so here we go. On the left, let's write down some steps here that I want to see. Okay, first step is I want to regroup the like terms. So step 1, regroup, okay, like terms. Okay, so I'm going to color code things to help you see things better. The like terms are the constants, first of all. The first two like terms, the 3 times the negative 5. And then the other two like terms are the variables. So I want to take a look at the 3 and the negative 5 here and group those up together. So I'm going to take 3 here times, that's a 3, times a negative 5. Let me rewrite this here better. So 3 times a negative 5. That dot is times. Then I want to group up the variables together. Why? Because you can only multiply like variables. So I want to take a look at the y here and then the y squared here. Those are like terms. Okay, so y times y squared. So I group up the constants. These are called constants. Okay, I group up the constants, and we're going to multiply those mentally. And then we multiply the variables using the exponent rules and then see what we get. Okay, so let's do it together. 3 times negative 5?
Negative 15.
Good. Okay. Now y is y to the first power. Y is the same as y to the first power. And so you have y times y squared Adding exponents, we get y to what power?
Y to the third.
Okay. Yeah, you can say y to the third, or you can say y cubed. Okay? So you get y cubed right there, and it's being multiplied. Everything's being multiplied there. So I showed the regrouping because the order doesn't matter, the grouping doesn't matter, and I just grouped up the like terms. Okay, so let's try it again. So here we go. This time we got 3 monomials, and we're going to multiply them together. So we're going to group up the constants first. Okay? Oh, wait a minute. Let me back up here. Step 2. Step 2, we simplified. So write that down. Step 2 is simplify. So you regroup first and simplify next. And that's exactly what we're going to do as we take it through the problems here. So on the second example, the 10, we have to multiply the 10 times the 2/5 times the 3. Again, everything's being multiplied. So here we go. 10 times 2/5 times 3. Group up the constants.
Do we do it in that order?
Well, I read from left to right, so you can switch the order if you want. But I just do it like that just because I'm reading from left to right.
Okay.
Okay? And then you group up the variables, x times x cubed times x. And you'll see the x's here, here, and here. Okay? And now that's step 1, regrouping. And now you just have to multiply. And when you multiply fractions, it's a piece of cake because all you do is multiply the numerators. Let's do it together. 10 times 2 times 3. Okay? And then divided by 5. 60 divided by 12. Excuse me, that's the answer. 6 divided by 5 is 12. Or, you could do this. Watch this. Who's thinking this? What's 10 divided by 5? Who thinks division first? Yep. 10 divided by 5 is 2. Now let's take 2 times 2 to get
4
times 3. 12. So it might be easier for some of you guys to divide first and simplify before you multiply. We've talked about that extensively too. Bless you, bless you. So this is 12. Okay? And then here, anytime you see a variable without an exponent, you get to assume that those exponents are 1. Okay, right here, when you're multiplying, you want to add exponents. All right, here, so you got x times x cubed times x. Okay, gives me what? X to the 5th power. Very good. So 12 times x to the 5th power is our end result. Okay? So we're going to show a regrouping, and then we're going to simplify. So let's continue here. Let's regroup here. We've got 2 constants to deal with. We've got the -8 times the 3/4, so we want to regroup there. So -8 times 3/4. Notice how I bring the -8 above in the numerator, because you can write -8 as -8 over 1. It's as a fraction. Eyes up here, guys. Come on. And then you want to group up the p's together. So let me say I see p here. I see p squared here. I should have changed color there. P times p squared. So p times p squared, that will give us something. And then lastly, I see the q times q cubed, or q to the 3rd. All right, so q times q to the 3rd. All right, if you really know what you're doing in mathematics, you could write down all the steps and then develop those good habits like I keep saying, and then simplify and get really good results. Okay, so here we go. Let's do it this 2 different ways. Eyes up here. Let's multiply first. What's 8 times 3, everybody? Come on, everybody. 8 times 3?
24
Divided by 4?
6.
Okay, now let's divide first instead of multiplying. What's 8 divided by 4?
-2
Okay, -8 divided by 4 is -2 times 3.
-6
Very good. So if you want to show your division, you show it like this here. -8 divided by 4 is -2 times 3. Gives you a -6 there. So you simplify. P times p squared is? Say it again. P cubed. You can say p cubed or p to the 3rd, either one. So p to the 3rd there. And q times q to the 3rd would be q to the 4th power. Add exponents there. Okay, so you have q to the 4th. So you have -6 times p to the 3rd times q to the 4th. Okay. Give me a show of understanding so far. This is full. Pretty good. Not so good. Where are you at? It's not bad so far. If you're here, which some of you guys may be, don't worry about it. We're going to do a lot of examples and get some practice. Okay, this one's a little bit different on D. Check this out. This is a product to a power. This is called a product. Why? Because you're multiplying 2 things. You're multiplying 7 times x cubed there. And you're taking a product to a power. So what you want to do here is you want to square both factors. And let's write that down. Square both factors. This is something that you've heard me say in the past when we dealt with exponents. Okay, when you square a product, you square everything inside the parentheses. Okay, so everybody, yeah, there you go. Tell the person next to you, square everything. Okay, we've done this before. Now, we're not skipping any steps, so we're going to write it out. 7 squared times, okay, x cubed squared. Okay, so we square the factors right there. That's step 1, and step 2 would be simplify. Okay, you help me out a little bit. 7 squared? 49. There's your simplifying right there. Now here you got a product, or excuse me, you have a power to a power. The rules are right above in the beginning of your notes. So if you need to read them, go ahead. A power to a power. What do we do to the exponents? No, read. Okay. Tell me again. Okay, power to the power, you multiply exponents, so you get x to what power? Okay, so you get 49 times x to the 6. Okay, multiply exponents. That's why I reviewed the exponent laws above, and that's why we put them above, so you can refer to those at all times. Okay, are we good? Okay, now this one here, we've got to handle the first term, and then we've got to handle the second term. We've got to square the first monomial and then cube the next one. So we have two different things we got to do here first. Okay, so here we square everything, square all factors. And then here you cube all factors. Again, I'm not going to skip any steps today. I'm going to take it step by step because we want to develop what?
Good habits. Good skills.
That's right. Good habits, good skills. And then we're going to step it out. Okay, here we go. Well, the factors are 2 and x cubed here. We're going to square those. So I got 2 squared times x cubed squared. Okay, that's my first. Squaring the first term there. And then I've got to cube the second term. I got to cube the 3, and I got to cube the x to the 5th. So here we go. I'm going to do that in blue. So we've got 3 cubed. Now I put dots in here because everything's being multiplied here. Everything. So times 3 cubed times x to the 5th cubed. So I squared the first term, then I cubed the second term, and now we simplify everything. Okay, so here we go. Work with me here. 2 squared? 4. 2 squared is normally 4, especially on Tuesday. Oh, especially on Wednesday. Especially every day, actually. Okay. Okay, x cubed squared? Yeah, x to the 6th power here times x to the 6th power. 3 cubed is 3 times 3 times 3. So let's do it together. What's 3 times 3? 9 times 3? Times 27 here and here. And then the last one, we got a power to power. We got to multiply those exponents, so we get what? X to the 15th. Okay, gentlemen. Okay, now we regroup. Okay, we have to regroup, and we have to multiply the 4 and the 27. So here we go. So 4 times 27, and then I'm going to group up the like terms, x to the 6th times x to the 15th. Everything's being multiplied, and remember, in multiplication, the order doesn't matter. So regrouping, switching the order doesn't affect the multiplication, doesn't affect the product. Let me see, 4 times 27 is 4 times 20 plus 4 times 7. 108. And you just multiply on the side, you can see it. When I multiply that 4 times 27 in my mind, I go 4 times 20 is 80, 4 times 7 is 28, and then I take 80, 20, and 8, I get 108. Does anybody else do it like that in their mind?
No.
Look at that. There's quite a few people out there. Okay, so let me see. This is the first rule here. When we're multiplying 6x's, then multiplying 15, how many are we really multiplying? Okay. Let me see, multiplying 6, yeah, 21. So how do you say that correctly, though?
21st power.
X to the 21st power. So 108 times x to the 21st power there. And that's how it's done. Okay. Now that's not enough to really get it sound in your mind. So let's try it. Let's turn on the next page. I'm going to pause the video now, and here's where I want you to practice first and then stop after the first example here. And don't work ahead of me too much here. Just go one example at a time. So let's practice and then check. So I'll pause the video now and give you time to practice. Example F only. Stop after F, and then wait for me to summarize in a minute. Let's check it out. So regrouping the constants, 2 times -7, and then times y times y cubed. Right here, 2 times -7.
-14.
Okay, -14. Y times y cubed.
Y to the 4th.
Okay, who got that one? Go like this. Go like, yes. All right. Okay, now something a little bit more challenging than G. Go for it. Okay, let's summarize and let's check here. I'm going to regroup the constants first. So I've got 30 times 3/5 times 2. Got to regroup the constants first. And then the x's here. I got x times x to the 4th times x. Okay, now watch the simplifying here. I'm going to divide first. Okay, what's 30 divided by 5? Okay, so right away, who did that right there? Who divided first? Very good. And 6 times 3 is 18, times 2 is 36. Okay, so one more time. 2 times 3 is 6, times 6 is 36 here. Let me see, x to the 1st times x to the 4th times x to the 1st again. What's that? Ooh, very good. Okay, go ahead and try each now. Okay, I'm going to regroup first. So -24 times 3/8. And then I'm going to group up the p's. P squared times p cubed. And then regroup q times q to the 5th. Okay, here we go. I'm going to divide first. -24 divided by 8 is? That was pretty weak, guys. That was -3. What's -3 times 3? Okay, boom, we got -9 here. What's p squared times p cubed? P cubed? Say it again.
P to the 5th.
You got it, man. P to the 5th here. What's q times q to the 5th? Q to the 6th. Everything's being multiplied there. Okay, next one. Go. So on the next example here, we've got to cube everything. Everybody say cube everything. Okay, so 5 cubed times x to the 5th cubed. Okay, here we go. Look at me. What's 5 times 5?
25.
Times 5.
125.
125. Okay, and we have a power to a power, so what's x to the 5th cubed?
X to the 15th power.
X to the 15th power. Okay, now J's a little bit more challenging. Try that. Okay, let's summarize here. On our first term here, this one here in yellow, x to the 4th cubed is? Say it again loudly. Yeah, power to the power, you multiply exponents there, so you get x to the 12th here times something now. So you have to take each factor to the 4th, so I'm going to step it out, as I always do. I have to take 3 to the 4th and then x to the 7 to the 4th. Now, 3 to the 4th, look at me up here. You have to multiply 4 threes together. And you could do it in order. 3 times 3 is 9, times another 3 is 27, times another 3 to get 81. But it's a lot easier if you regroup. Watch this. You're multiplying 4 threes. And then you do the Spock. Ooh. All right, you do the Spock. And what's this? What's 3 times 3 here? 3 times 3 here? What's 9 times 9? So if you group up the 3's in pairs, it's a lot easier mentally because everybody knows what 9 times 9 is. It's 81. That's easier than 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay, so right here, this is 81. I'm going to bring that in front because typically you bring the constant in front. Did you guys catch that? Times x to the 12th up here. Now, what's x to the 7th time, or to the 4th power? Times x to the 28th. So you know what? We're not done here because we're multiplying like variables here. So at this point, when you multiply like variables, what do you do to their exponents? Because if we're multiplying 12 x's first and then another 28, man, we're multiplying a lot of x's there. Excuse me? How many exponents, or how many x's are we multiplying? I know, what is? How many is 28 and 12? So how do you say that properly? X to the 40th power. So 81 times x to the 40th power there. Okay? All right, last one. Give it a shot. All right. So we got a first term here, we got a second term here. Let me summarize. I got to square everything in the first term. So 5 squared times x to the 6th squared. And then on the second term, I got to take it to the 4th power. So times 2 to the 4th times x to the 7th to the 4th. All right. Okay, so here we go. 5 squared gives me 25. X to the 6th squared. Say x to the 12th power there. Okay, to the 4th, we can do the Spock again. All right. 4 times 4, 16. Or we can go, eyes up here. What's 2 times 2? Times 2? No, come on, that's terrible. 2 times 2 is? Times 2? Times 2? Whoa, 16. God help us. All right, and what's x to the 7th to the 4th power? Okay, now I've got to regroup. 25 times 16 first, and then x to the 12th times x to the 28th. Let me see, 25, listen to this. 25 times 16 is like 16 quarters, and everybody knows that 4 quarters equals a buck, or like 4 times 25 is 100. So how many groups of 4 are there in 16? Listen, how many groups of 4 are there in 16? How many groups of 4 are there in 16? Come on, 4 times 4 is 16, right? What's 4 times 25? 100. Now you got 4 of them. 400. 16 times 25 is 400. So 400 times x to the what power? To the 40th. Okay? And that's how it's done, my friends.